Something I forgot to tell you here in part 2, we'll just attach to part 3 here. If you have to take the derivative of something, like 3x times x plus 2, you cannot take the derivative of the first part, take the derivative of the second part, and then just multiply them together. If you do that, you kill puppies. Simplify first. So, in this case, this is going to be 3x squared plus 6x. Now I take the derivative of it. F prime of x is going to be, well, 3. Derivative of x squared is just 2x. Derivative of 6x is just 6. So it's going to be 6x plus 6. Let me show you what happens if you don't simplify first. If you say f of x is equal to 3x times x plus 2, and you say, hey, I'll just take the derivative of the first part. The 3x is just 3. Derivative of x is just 1. Derivative of 2 is nothing. So the derivative of this function is 3 times 1 plus 0 is just 3. Wrong. That would make it a straight line, and this is obviously a parabola. Wrong. In the next section, we'll learn about the product rule. Not yet, but we'll get there. Don't do that. So always simplify first. Just like right here, I can simplify this. 2x squared over x. I'm going to take the derivative of this whole thing. It's all over a common denominator, so I can just split it up. 4x divided by x plus 1 divided by x. Derivative of 2x squared divided by x is just 2x. 4x divided by x. Just 4. I'm going to rewrite this. 1 over x is x to the negative 1. Now I still haven't taken the derivative. That's okay, because now it becomes easier. Derivative of 2x is 2. Derivative of 4 is 0. This is going to be, bring the exponent down, negative 1. X to the negative 1 minus 1 is negative 2. So 2 plus, or rather 2 minus 1 over x squared. Simplify first. This part right here should seem like review to you, because it is. Average speed. Remember when Curious George fell out of a tree and we had to find his average speed on the trip down? Well, basically the same thing here. To find the average speed, just a moment. I'm going to find the average speed of something that was launched 70 feet up at 70 feet per second from a starting height of 30 feet. So maybe we've got the rock quarry here. Okay, and let's say we got tired of somebody in class. I don't know. Who could we possibly get tired of? Oh, we'll say we got tired of Ben. Yeah, he's not in class anymore, but we're still going to say we got tired of him. Just kidding, Ben. You know I like you. So we're going to launch Ben up in the air. 70 feet per second. He's going to go up, and he's eventually going to come down. We want to find his average rate of change, also known as his average velocity. Well, average velocity is just how long it took him to go from point A to point B. That's just slope. Average velocity is just going to be his height at time 0 minus his height at time impact. all over the time, the total change in time. And you may say, Mr. Kuhne, how can I find this? Well, how can I find when I hit the ground? Well, that's the great thing about graphing calculators, or Desmos. That's right, I graphed it. I just found the point right there. Yes, you can use your graphing calculator and graph it and find the point where it crosses the graph. You need to know how to do that. If you don't, you're gonna die. Use your lightsaber. But I just did that. I did it on Desmos because I don't have my graphing calculator here. I know. I'm a horrible, horrible math teacher. Please forgive me. Anyway, so time it takes him to impact is going to be 4.768 seconds. So his starting height, h of 0, well, if I plug 0 in for this function, I'm going to get, just 30. What's his height at impact? Right here. When he hits the ground, that's going to be 0. And the total change in time is going to be 0 minus 4.768. And so we get our calculator. Remember, always go 3 places beyond the decimal. $30 divided by 4.768. Negative 6.2919 feet per second. That's his average speed. And you may say, Mr. Kuhne, there's no way he could be going negative 6.29 feet per second. When he lands, you are correct. He was shot up at that speed. Shot up much faster. If he shot up much faster, he's going down, and he's going down below where he started. He should be going even faster when he hits. But what we're talking about here is the average. The average speed, if he went straight down there. So here's the big idea. If you need to find the average rate of change, use the secant line. Use the secant line for the average rate of change. Secant line just mean f of b minus f of a all over b minus a. That's the average rate of change. Now, how fast is he going when he actually hits the ground? Well, he hits the ground at 4.768 seconds. To find out how fast he was going, we need the tangent line right there. That will be his velocity at the exact instant he hits the ground. So, h of t is going to be negative 16t squared plus 70t plus 30. H prime, the derivative, also known as the velocity. The derivative of a position function is the velocity function. So, we've got to bring this 2 down in front here, times the negative 16 is going to give me negative 32t. Derivative of 70t is just going to be 70. Derivative of 30 is just 0. I'm not going to write that on there. So, what was his velocity at 4.768 seconds? Negative 32 times 4.768 plus 70. Let's find out. $32 times 4.768. Subtract 70 from it. He was going a blistering negative 82.576 feet per second. just for fun, if you want to terrorize our good buddy Ben, you can tell him, hey, Mr. Kuhne shot you off a cliff, you smashed into the bottom of the canyon, or the nature park, the quarry, and you were going 82.576 feet per second. Figure out what that is in miles per hour. Might give him some idea of how much we like him. Just kidding, Ben. You know I like you. All right. Horizontal tangent. So, how do we find a horizontal tangent? When does this function have a horizontal tangent? Well, let's say this is something else that got launched up in the air. So a starting velocity of 40. When does it have a horizontal tangent? This is actually similar to a problem that I couldn't remember how to do on the SAT using just algebra, so I had to use calculus. Horizontal tangent. Well, horizontal tangent would be when it reaches its peak right here. Horizontal line. What's the derivative of a horizontal line? What's the derivative of that line right there? That would be 0. So horizontal tangent tells us we got to find when f prime of x equals 0. That's a huge idea right there. Horizontal tangent is basically asking us when does f prime of x equal 0. So for our function, we've got to find h prime of t is 0. So what's the derivative of this? Well, it's going to be negative 32. Negative 32 t plus 40. When does this equal 0? Let's see, divide that by 8. 5, 4, 1.25 seconds. You may say, Mr. Kuhne, why does anyone care about that? Well, let's go back to Ben's problem here. We can figure out how high Ben went using simple calculus. H prime of t, we said, was negative 32 t plus 70. We can find if we can find the horizontal tangent right here, we can find out when he was at his peak height and how high he was. So, negative 32t plus 70 is 0. Well, 70 divided by 32. .875 seconds. So now, let's figure out how high he went. H of 2.1875. Just plug it in. And if we work it out here, I believe he ends up going up 106.6 feet in the air. That's how high Ben went. All right, so what we've covered here, it's a lot. We've covered the power rule, the coefficient rule. Basically, just shove the coefficient to the front and simplify later. Just deal with the function. Derivative of sine of x is cosine of x. The cosine of x is negative sine of x. the sum and difference rule here. It's got to take, if you're adding two functions together, just take the derivative of each part separately. This also works for subtraction. Horizontal tangent, that's when you have to find when f prime of x is equal to 0. Always simplified first. Average speed is the secant line. Instant speed is the tangent line. When f prime of x. F prime of x, this is f of b minus f of a over b minus a. This function secant line means find this. Tangent line means find that. Thanks for watching.